Here's some of the homework assignment from section 3.2 in the Algebra 2 honors course. In the numerator, you're multiplying like bases. So when you do that, you add your exponents. So you have negative 2/5 plus 2/5, which makes the numerator 120 to the 0, and anything to the 0 is a 1. So the numerator cleans up pretty nicely. The denominator is 7 to the negative 3/4. If you have a negative exponent, it simply moves to the other side of the fraction and becomes a positive exponent. So I think this is the way we're going to leave the answer. They might write it as power over root, so it would be the 4th root of 7 to the 3rd. But based on how they give the question with a fractional exponent, I assume they want their answer with a fractional exponent. Number 9, you are dividing like bases. If you divide like bases, you subtract exponents. So 2/5 minus 4/5 is a negative 2/5. As I just said, if you have a negative exponent, it goes to the other side of the fraction and becomes a positive exponent. The problem is this is a 5th root in the denominator. You're not allowed to leave radicals in the denominator. So I'm going to assume, to get the answer that the book has, they might multiply this by 11 to the 3/5 over 11 to the 3/5. In other words, a fancy form of 1, so you're not changing the value. But why 11 to the 3/5? What happens if you multiply, you add the exponents? What's 2/5 plus 3/5? 5/5 or 11 to the 1st, which makes your denominator a non-radical. On the top, you would have 11 to the 3/5. Let me look in the textbook and see how they leave their answer. But I'm assuming they don't want radicals in the denominator. Can't get that. Maybe that time. I always recommend you match the answer in the back of the textbook. What they do is they turn this into power over root. So it is a 5th root of 11 to the 3rd. So the 5th root, I believe they have 1331 over 11. So this would be their answer. I'd probably take either of the two boxed in answers, but they are equivalent. Let's take a look at number 13. 13, here we have 16 to the 5/9 times 5 to the 7/9. So that means these are both 9. Well, we could multiply exponents because it is a power to a power. There's a couple of approaches. What happens if you take 5/9 times negative 3? 5/9 times negative 3. Does that give you negative 15/9? Or maybe you can see it goes in there 3 times. Negative 5/3, I believe. And when you multiply here, 7/9 times negative 3, negative 3 over 1, that would go in there 3, and you get negative 7/3. So I don't know if this is the best approach, but if we are to have a power raised to a power, you could just multiply the exponents as I did. Now you can't have negative exponents, so they'd have to move to the other side of the fraction. Okay, I'm going to keep going. The negative exponent moves it to the bottom or the other side of the fraction and becomes a positive exponent. So that would be to the 5/3, and that would be to the 7/3. So this would be, I don't know how we want to do this. We need to turn these into whole number exponents. So I need to probably turn that into 16 to the 6/3. So with 16 to the 1/3, would that make what on the bottom here? Let's get rid of that. What would that make the 16 to what power? adding exponents. 1/3 plus 5/3 is 6/3, or 2. Basically, I'm getting rid of the fractional exponent. 7/3 probably has to turn into the next biggest integer, like a 9/3. 7/3 plus 2/3 would make 9/3. So what does that make on the bottom? 5 to what power? 5 to the 9/3, which is 5 to the 3rd. Now I'm going to take 16 squared times 5 to the 3rd, which is 125, and see what we get. Okay, this gives me 32,000 in the denominator. On top, I would get 16 to the 1/3 times 5 to the 2/3. That makes the 3rd root of 16 to the 1st, and the 3rd root of 5 to the 2nd. So that would be the 16 times 25, which is 400. Now I know that 8 goes into 400, and 8 has a 3rd root. So I could do the 3rd root of 8 times the 3rd root of 50 over 2 times, what would that be, 16,000? The 3rd root of 8 is 2. Those would cancel. And the answer they have is the 3rd root of 50 over 16,000. That's a tricky one. Much harder than 35, because 35, all you're doing is adding 1/8 of this plus 3/8 of the same thing. 1/8 plus 3/8 is 4/8. So you have 4/8 of this 4th root of 7. 4/8 is 1/2. So some of these later ones are actually easier than ones like 13. Okay, let's see what else we have here. We did 9, 11, 13. Let's look at, I don't know, 29. We want a 4th root of 144. What is 2 to the 4th? Is it 16? So we could write this, I believe, as 3 over the 4th root of 16 times the 4th root of 16 times 9 is 144. And what is the 4th root of 16 here? Should be a 2, right? Times the 4th root of 9. Now you can't leave a radical in the denominator, so I have to turn this into something to the 4th. 2 to the 4th is 16. I don't think I can turn 9 into 16 using multiplication. But 3 to the 4th is 81. And 9 is a power of 3. So perhaps we should multiply this by something that's going to make it the 4th root of 81. So let's change this and let's go to, how about the 4th root of 27? No, what's 27 times 9? That's not it. What would I want? I want a 9, don't I? Because 9 times 9 would make 81, and the 4th root of 81 is 3. So I'm multiplying by a fancy form of 1, so I get 3 4th roots of 9 on top, 2 times the 4th root of 81 on the bottom. What is the 4th root of 81? 3. Those could cancel. And I'm hoping that their answer is the 4th root of 9 over 2. Now I'm going to approach it in a different manner, and I think this could even be simplified further, because 9 is a power of 3, and the 4th root, 9 is 3 squared. The 4th root is a 1/4 power. What do you do with a power to a power? You multiply, so that gives you 2/4 or 1/2. So I think their answer is going to be this one. Let me check. It might be the best approach on 29. I can tell you, however, on 31, they're both powers of 3. 144 is not in a straight power of 3. 3 to the third is 81. I'm sorry, 3 to the fourth is 81. But 3 to the fifth would be 243. That's too big. 9 and 27, on the other hand, are powers of 3. 9 could be called 3 to the second. And the third root means the 1/3 power. 27 could be called 3 to the third, and the fifth root means the 1/5 power. A power to a power, you multiply exponents. A power to a power, you multiply exponents. Now, I'm dividing with like bases. What do I do with the exponents when I divide with like bases? Well, you should subtract them. So you get 2/3 minus 3/5. What is 2/3 minus 3/5? Well, you need a common denominator of 15. So that would be 10 minus 9. Would that make a 1/15? So I think this is 3 to the 1/15. Remember that it is power over root. So it is the 15th root of 3 to the first power. Okay, 31, 29. Let's see what else we have. Are these both third roots of 5? Then you should be able to just combine them. What's 3/5 of an apple minus 1/5 of an apple? 2/5 of that same apple. Any questions on 33? Now, these are both 7th roots on 37. This is the 7th root of 2. I need to probably turn this into something that has a 7th root of 2. 256 divided by 2, I believe, to be 128. So you have -6, 7th root of 2, plus 2 times, because this is multiplied. What is 2 to the 7th power? Well, it's 128. So the 7th root of 128 is 2. So you have -6 7th roots of 2 plus 4 7th roots of 2, because 2 times 2 is 4. -6 apples plus 4 apples is -2 apples. So you'd have -2 7th roots of 2. Okay, after 37, let's see. Somebody asked me 47, 45. So we'll look at these. We need to divide like bases. So we're going to subtract exponents. So you have 2/5 minus 1. 1 could be called 5/5. Y to the 1 minus -1/3. Again, if you're dividing like bases, you subtract exponents. So that becomes x to the -3/5. This becomes y to the, you add that, so 3/3 plus 1/3 would be 4/3. Any positive exponents stay where they are. If there are any negative exponents, they go to the other side of the fraction and become positive exponents. Once people reach high school, I never accept negative exponents or fractions in fractions or double signs. There's certain things we need to move on from. So hopefully we won't leave negative exponents. I could change these to radicals, but how's the question asked? With radicals or fractional exponents? It's asked with fractional exponents, so I'm assuming the answer should be in fractional exponents. 45, on the other hand, is asked in radicals. So my answer should be in radicals. So can I do this? Is there a 4th root of 81? Is there a fourth root of x to the fourth? Well, 3 to the third is 27, so 3 to the fourth is 81. The fourth root of x to the fourth is just x. Technically, if you take an even root that yields an odd power, you're supposed to put it in absolute values because the primary root is always positive. I hope these help. Good luck.